So what else you need to know is that the practice of the linear equation, which we have discussed. So linear equation and trigo is sufficient. These two are sufficient to progress in kinematics with ease. If you're good with linear equation, if you can write the equation of a line by looking at the graph, you can do a lot of good things in physics. Okay, so I think I have given the very basic, the very superficial view of limit, and the limit chapter in mathematics is basically to take a given expression from the undefined state towards the defined state, right? This is what we discussed in the last lecture. So trigo is, sorry, limit is all about shifting the given expression from one form, which is undefined, to another form, which is mathematically feasible, plausible, whatever you can say. And based on that idea, we are going to learn the next topic, and that is called differentiation, or you can say derivative. So we'll start with the geometrical meaning first, then we'll go for the operator meaning. So today we're going to study something called the geometrical meaning of dy by dx. Okay. So what dy by dx mean to you geometrically? This is what we are trying to understand. So when we study differentiation in terms of mathematical equation or mathematical graph, generally we get biased towards this idea. But differentiation is so, you can say, efficient. It's like a method, or you can say it's a science, pure science, which we employ in variety of sciences. It is not only restricted to physics. Of course, you learn in mathematics, you learn in physics, but the actual application of derivative is, you can say, economics. The entire idea of the stock market, which is called derivative market also. So we have differentiation there also. All the advanced economics deals with the differentiation. If you talk about the machine learning, it is purely based on differentiation, the derivative. But of course, there the derivative will be in different dimension. The mathematical symbols will change, but the core idea remains same everywhere. Now here we are trying to understand something called the single dependency, like when we have only one dependency of a dependent variable. So dependent we call y and independent we call it x. So we are trying to say that the y will have dependence on only one thing, okay, not on the other thing. Let's say, but if you are cooking some recipe, and if you're cooking, if you're making some recipe, then the recipe is a multi-variable function. It depends on variety of spices that we use. So we have a set of ingredients that we use to, to make this recipe ready. And if you know the idea of recipe, you know there is idea of proportion. Okay. So you add something. So you add salt and you check the taste, that how the taste is changing when we add the salt. Okay, how the taste is changing when we add some spice, let's say turmeric powder. How the taste will change if we add some extra spoon of, or a tablespoon of some other spices, let's say coriander powder. So if recipe is a multi-variable function, then every ingredient is the variables. Okay. And if the taste is the output, let's say taste is the output, which is like y. So here y is a function of a n number of ingredients. So that's called the multi-variable function. And you are always trying to understand that if I make some recipe, and if I next time if I'm making the same recipe, and if we have the pre-described ingredient and its quantity, you want to make some experiment, and what you do is you change the proportion by a little bit, and you see how the overall taste will change. Okay. So now in case of multivariable, we go for something called the we check one independent variable at one time. So we first check the taste with salt. We check taste with maybe some spices. We check the taste with some addition of edible oils. You add ghee, or you add different types of oil, maybe groundnut, peanut, or whatever, sunflower, and so on. So this is the entire meaning of derivative. Derivative is in our day-to-day life. We always try to check something by altering or tweaking some of the variable. And we see how we try to understand the effect that if I change this variable, then what will happen? Okay, if you add more water, then how the test will get hampered. Okay, if you add more oil, then what will happen? Okay. Will it be too greasy to eat or will it be really nice to eat? So the whole idea of derivative is in our day-to-day life. We see everywhere. Now, luckily in mathematics, at this stage, when you are studying for JEE preparation, the entire dependency is only one ingredient. We have just one ingredient. Okay. Now you may be thinking that if there is only one ingredient, then the change will be similar. Okay. So let's say uh, even with single ingredient, we can create something. I mean, a lot of things. So with a single ingredient, if I say milk, so if milk is a single variable, then you know the derivative of milk. So we have the paneer, the cottage cheese. Again, it's a derivative of milk. We have ghee, which is also the derivative of milk. We have sweets, chocolates, and n number of things. That is derivative of single variable. It's called milk. So milk is a very universal independent variable, and it gives rise to the variety of things. Okay. So derivative means what you can produce by, you know, so if you have some output in your mind, let's say if you think of something as output, and if you know that that output depends on some of the input, let's say here, let's say you want to make some ghee, I mean, and you have a milk, then you know there is a lot of process from the milk to the ghee process. So you boil the milk, you let it calm and cool down, you get the layer, the creamy layer over the surface. You remove the layer which gets like the coagulation, and the coagulated layer we remove it and we keep it on a, I mean, pan. We heat it, and then the derivative comes out of it. There is a process. So derivative means like you try to derive something, okay, out of something. And when I say dy by dx, try to understand the physical sense of it. So you're trying to, you have a dependent variable y, and you are trying to check that how the y will behave. Okay, if I tweak the x, if I change the x, so how my dependent variable will react to a changes which happen on the independent variable. That is the meaning of dy by dx. So later on, in case of multivariable function, when the dependency is more than one ingredient, okay, there we introduce something called the partial derivative. That okay, if I only change the salt, then how the test will change. So my test is a function of multiple variable. Then I take one at a time, and then we check the variation in the output per unit change in the one of the inputs. So when we have multiple choice, then we call something called partial derivative, which means you believe that all the other ingredient is not going to change. Only you change one of the chosen ingredient, and then you try to see its effect on the output. So this idea of trying to understand the variation in the output due to a small tweak in the input, we call the ratio is called derivative. So basically the derivative is of course it's a change of output per unit change of input. But to say dy by dx, okay, we always make sure that the change is the smallest possible change. Okay. So if you want to find the dy by dx, if we want to see the smallest change or the effect, then the only criteria is that don't make a big change. Okay. You change the proportion by a tiny amount and then check the tiniest change in the output. So when we bring the change to a very small scale, when the change itself is as good as zero, then we call derivative or the dy by dx. Okay. So derivative is basically the ratio of change of output upon change of input. So before the word derivative, we used to use the word called slope. Okay, in mathematics. Now slope is a mathematical way of saying the word derivative under certain situation. Okay, and when it comes to slope mathematically, then slope is defined for any two coordinate in space. Okay, so mathematically, because we have a very nice Cartesian coordinate system in which every point in space we can represent by some coordinate system. So you can think every axis as like one ingredient. Okay, so let's say if I take x and y as two ingredient, then z is the dependent variable on two of the ingredient x and y. Okay. When you draw yx graph, in a single planar graph, when you draw the yx graph, you only choose one variable as independent and one other as the dependent. If you make a three-dimensional graph, and of course, three-dimensional graph you cannot plot, but it is readily available through the computer simulation. And you can, I'll show you sometime the three-dimensional graph, how it looks like. It's very easy. You can go to the GeoGebra and I'll plot the three-dimensional graph. In a three-dimensional graph, one of the dimension I choose as a dependent variable, and rest two we call independent variable. Now, mathematically, we cannot plot something beyond two. So I cannot take beyond two dimension and we can represent it visually. So the moment we go for the three dimension, four dimension, or five dimension, then it becomes the part of something called abstract algebra or abstract mathematics. So we go to something abstract because you cannot see it. I mean, of course, you have to just have the sense that maybe there is something like a four dimension which does exist, and all the three variables are plotted against the fourth one, which is the dependent one. So when it comes to the plotting part, I mean, our syllabus is very much confined to the one variable and one one independent and one dependent variable thing. And in that context only we have to learn the entire thing. Okay. So it will have the wide application throughout your learning journey of science from now till you do the post graduation or maybe masters and maybe PhD, maybe postdoc, or you do multiple postdoc, you do research after that, and become some Nobel laureate. Till that journey, you have derivative everywhere, you can say everywhere. So in the higher dimension, what we introduce is called tensor. So the derivative is replaced by tensor. At a gradation level, you can say you will go with the idea of curl, divergence, and so on. And as you progress in life, I mean, of course, in mathematics, you will see like n-dimensional mathematics with very nice, very complex looking symbols. But those who study those things, I mean, for them, it is not very difficult. So recently, one of my students finished his PhD from the world-based University of Maths, whose alumni are like Bernoulli and Laplace are their alumni. He's from, and that's from the French University. I think international politics, something like this. I don't remember. So there, he was working on optimization theory, and optimization theory is basically, you can say, the advanced or much advanced concept of or layer of maxima and minima. What you call maxima and minima. You try to optimize the taste using various proportion of ingredients, and if it is so many variables comes into place, then of course we cannot do it manually. So of course we have various computer graphical technique, we have advanced matrices operation which does that for us. Okay. The same thing is also used for the machine learning, artificial intelligence. How the computer learn is the same process. They use the optimization technique, and what they do is they keep on changing. So the machine is having the ability to keep on tweaking the variables, and they keep on checking that if I change the first ingredient, how the test will change. So when we have like n dimension of ingredients or variables, then only machine can do all these changes over the months or the years. And before they come out with some algorithm or say this is the perfect way to do something, it undergoes zillions of computation before it gives you some idea. So of course, all these things are nowadays possible because of the extreme computational power that we have achieved over the years. Earlier it was not there. Earlier it was only in theory. Okay, and it is not like the machine learning, artificial intelligence is a new thing. It is as old as the math goes or as old as the physics goes. So these are very old concept, but earlier it was on a paper. Now it is actually being implemented thanks to the computing power we have achieved over the years. It is all about the computing power. In future, if you are going to implement the quantum computing, probably we can actually achieve any sort of computation or any sort of optimization we can achieve. So that is the future for you. When of course you will be part of that future. Hopefully, I may see at the end of my life. So the future is really bright, and don't study because this is just a part of JEE physics or JEE maths. It will have the repercussion throughout your life. I mean, those who do not know derivative, they always struggle. Whether you're a budding economist or you're budding data scientist, you're budding uh, astrophysicist, without the idea of derivative, the life will never progress even a bit, even 1 inch. So what we are trying to understand is a mathematical idea. So don't see this as graph or axis. See this as something more realistic. So when I plot something, you can always understand what I'm trying to plot. This is the dependency. I say a dependent variable. Okay. And whatever I put here as a symbol, I call this as independent variable. Now in future, when you're learning physics in this kinematics, you will see velocity here, time here, you will see acceleration here, time here, you will see displacement here, time here. So what I'm saying is the y and x are some abstract notation. Don't take y as the length or the height or the coordinate. Y is the name of the dependent variable. And you can put any name to it. It is not always one. Okay? You can put the name as you wish. It can be force, it can be momentum, it can be anything. I mean, the infinite variety of dependent variable, and there is again infinite variety of independent variable. And what you need to understand is that how the dependent will behave as I tweak. When I say tweak, it means as I change the independent one, how it responds. So you can say if it responds sharply, what does it mean? That a small change in the x, even for a small input change, the output will be much bigger, correct? Isn't it?
Yes.
So the meaning of sharp change is what? That as you tweak the first, the second will change very aggressively. So we say a sharp change. A very like slow change, it means even you change the x, the y will have like no response, or the change is very, very minimal. So if I plot any exponential graph, this is some sort of like this. If I plot an exponential graph like this, and if I call this as e power x, so if it is exponential graph, generally it will become very curved as you go. You can see that if you go equal blocks, if you make equal changes in x, let's say I'm taking this, I'll draw a few overlapping terms. 1, 2, 1. So I bring the other one here. I bring one here. So the first step of learning maths is to read the graphical thing. Like when you plot something, the first thing that we need to learn is how to read it properly. So to read it properly, you can see something interesting here. That this is the position of x. So you are here, and you move slightly ahead. So this is like a tweak part. Okay. So going from x1 to x2 is what? You tweak the x value. Now the next question is check the effect. And if you check the effect, what is happening? The height was this much. So for the first variable, this was the output, correct? So that's So if you remember, I said that every point on a graph, when you say something graph, a graph is simply a geometrical representation of what? Of locus of points, right? Which follow certain relationship. Okay. So this point on a graph is representing one pair of x and y. So for this x, if you add the ingredient x of this value, the output will have this value. But if you add the ingredient of this value, the output will change to this value. So you need to read the points on the axis separately. Now, if you look at the first part, which I have drawn, the change in x and the change in y, can you see the changes? So this part is called change in x. We can call it delta x. And this point we can call delta y. Understood? If I draw the same thing for the next bar, somewhere here, what do you expect? The changes are going to be more than before or equals to before or less than before? Do you see some apparent changes? Hello, hello. So if you are making a change, am I audible to you guys?
Yes.
Yes, sir.
So if you make a change somewhere here by the same value, because I'm keeping the change same just to represent something, the next change is same or different?
Same.
No, it's quite different. The change in y is how much? Do you see the change in y? Is it same as before?
So different.
Rugved, you can't see the difference.
No, sir. I saw.
So can you see the output is bigger than before, isn't it?
Yes.
Which means it is not necessary that when you bring equal change in the variable, the y will change equally. So what really matters is that you have brought this change, but you have brought this change beginning at this location. So being here, when you bring the same change, you get a different y. Let's call y delta y dash. But if you are here in the beginning and you bring a change, you get a different answer. So if I come here, let's call x3, x4, x5, x6. So if I start the change being at x5 already, so I'm already progressing a lot in x5. Okay. So maybe if you keep on adding a lot of salt, it may not be eatable at all. You won't be able to eat. So if I begin at x5 and if I bring a small change, the next change you can see is very, very sharp. So can we say that as the x will grow in value, the change will be sharper and sharper, isn't it? So we can see that change is growing drastically. And then you can get it for yourself that if you go further, you're going to see a hugely line, I mean, on the y side, a huge line, a big line. So what this is, the discussion of all this is that in a graph, the change will change the y for sure. Every change in x will bring something change in y. But the question is the change going to be same everywhere or is the change in the y will be different? That's the question. And if it is different, then can we say that change depends on the coordinate at which you are trying to bring the change? The starting of the coordinate, isn't it?
Yes.
So x1, x3, x5 are the three randomly chosen starting point. And being at this location, you try to bring some change in the independent variable delta x, and you try to see the impact on the dependent variable called delta y. So when you do this, the impact by changing or tweaking the independent one, you see that even though we bring the similar changes in the independent variable, the change in the output variable is not similar, correct? And that is why you can say that the tweak also depends on that at which point of graph you are presently in. Okay, so wherever you are right now will decide that how change will get affected. So can we say that even the ratio of change in y upon change in x, this ratio is a function of x? Can we say this ratio is a function of x? Can we say yes or no? Because the
Yes, sir.
ratio of the change is not same everywhere, no? So for every location we have different answer. So this is a function of x itself. But since I have already used a symbol that y is a function of x, then I cannot choose the same here. So I will make it a new name. And the general trend is we put a prime sign and we call del y by del x is a function of a new variable. It's a function of x only, but with some new relationship. The relationship is not going to be same as here. So under different relationship, this will have the dependency on x. Are you able to understand this? Read in this symbolic meaning. So if I say y is a function of x, which means y depends on x by some relationship, then the change will also depend on x by slightly different relationship. Okay. And you can also write like this. You can say that y equals to fx. Then I can say this is some other function gx. Yep. So both depend on x. The y is of course depending on x, but even the change in the dependent variable upon, or you can say per unit change in the independent is also depending on x. So you will get a different ratio at a different location. Now coming back from the equation of straight line, if you remember the delta y by delta x, which is the ratio of change of y and change of x, we have already given a name to it. What do we call this as? What do we call? The delta y by delta x is called? Come on guys, what do we call this? So there's a name for this in mathematics. Hello. This is basically y2 minus y1 upon x2 minus x1. So what do we call this?
Slope.
Very. This is called slope. So y2 minus y1 upon x2 minus x1 is called slope. So this is also called slope. Okay. So when you're trying to understand the derivative, actually you're trying to understand the slope meaning of slope. And slope is a mathematical way to give you the nature of change, that how sharp or dull the change is. Is it a very rapid change or is it like negligible change? So how the output is responding to the change in the input, and that various way of saying this. So in different contexts, it will have different meaning, but mathematically we call it slope. Okay. Now the meaning of derivative is, you know what is the meaning of derivative? So what is the meaning of dy by dx? So we'll come to that in a different way. So someone is trying to find the dy by dx. The dx is a number which tends to 0. What does it mean? This is the smallest possible tweak that we can generate conceptually. Let's call it the smallest possible tweak. Okay. So let's say if you have a protector which you use to find the angle, and then it will have lines drawn. And how many lines are drawn in a protector to represent the angle? How many? Tell me. So if you have a D, then how many lines you draw to represent the angle? Tell me, guys. You say 0, 1, 2. This is 180. So basically, you draw 180, or you can say 181 to be very precise, lines to represent the division of angle. So what is the least you can measure here? 1 degree. So the smallest thing that you can measure here is the 1 degree. Understood? If you draw 360 lines in this same angle, the smallest you can read is now half degree as per the old definition. Similarly, the dx is the conceptual way of saying that what is the minimum possible tweak that is possible in the independent variable, and then you try to see the change or the effect in the y. That is the meaning of that. So generally, the dy by dx symbol was adopted later on. Earlier, it was written like this: limit if the change is very small and as small as 0, for such changes, what will be its value? So when you try to find the ratio of the dependent and independent, I mean the variable, and if you assume that the change brought in the x is very small, then the value of this ratio we call dy by x. Is this clear, guys?
Yes.
So let's say we have some random function and it depends on 3 ingredient x, y, z. So it's a function which depends on 3 variables. And now I would like to know what is the del psi by del. I'm not del what, because we have 3 choices. So you will say limit delta x tending to 0. So we are trying to understand this. Now, because we have multiple choice, out of which we are going to choose only one, preferably, then to make the sense out of such notation, we use symbol. This is called del symbol, del. So instead of here we call dy by dx, but del represents that how the dependent variable will change per unit independent variable, assuming other variables are not changing. Okay. So if I make a delta y equals to 0 and delta z equals to 0 and delta x tending to 0, because I am trying to bring some change in x, but I'm not trying to bring any change in y, I'm not trying to bring any change in z, then this is called partial derivative. Understood? So that is the meaning of partial derivative. You you do not change other variable, so other variable will behave as if they are constant, and because they will behave as if they are constant, then you can change the x. Now, what is the benefit of this mathematically by defining something partial derivative? So as I said, we cannot plot graph beyond how many dimensions? How many variables we can plot to see visually? Visually, we can only plot how many variables? Tell me. Hello, guys. Anyone? 2. So we cannot plot more than 2. Let's say, and but you are when you're making some recipe, the variables are not x, y, z. It may be x1, x2, x3, and dot 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 xn variables. So first of all, we cannot plot such graph in which these are variables now. X1, x2 are variables. Now we cannot plot it. So what we do is we only plot the partial graph. Like take all other variables as constant, and then you can plot x1 and z. That is possible. So when you plot z versus x1, then you have to first of all make everything else as constant. And if everything else will behave as constant, then we can plot the variation of again these two. So in this case, if I draw some graph and if I find some slope at a point, then this will be called the partial derivative del z by del x1. Because here we don't have exactly one variable, rather we have n variable, but other variables, if I treat, then I won't be able to plot. So to make it simple, we do this kind of adjustment. So the idea of partial derivative came into picture, that in a multi-variable scenario, you bring a change in one of them and you see the impact partially dependent. So this is partial means you check the partial dependency, that how partially z depends on x1. So in a real life, if we have, let's say, 10 variables, then I will tell you the reality. So it is same with the all the machine learning thing which happens today. So what they do is they pick up a lot of inputs from the internet, your search criteria, you search something. So let's say in one fine day, some of you search 10 items on Amazon. So they have the predefined algorithm. They will see the past track record. What is like most probable thing that you buy generally on the Amazon, and depending on the month, what you buy. So what they do is they take all the 10 inputs, they plot each graph separately, and then see in which case the graph is very sharp, in which case the graph is almost like no changes, and they exclude or throw out such variables. They reduce the number of variables on dependency because others are not making much bigger changes to the output. Now these ideas are now very much commonplace nowadays, and we will also see in future, because your future is going to be this one. So you are going to be surrounded with the ideas of artificial intelligence and machine learning and so on. So you're going to deal with the partial derivative more than the exact derivative. So dy by dx is called the exact differentiation. And why we say exact? Because we have only one dependency. So there is no question of partial, it's a direct dependency and unique dependency. And okay, multiple dependency I have already discussed. So now we can come back to the derivation part. What exactly we mean by the dy by dx. So to explain dy by dx, I can draw any graph, but I'll choose a graph like this because that's easy for me to explain. So generally I take this graph. What I'm showing is a part of graph. It is not the full graph. Sorry. And now again we'll restrict our discussion to the one variable, because that is our syllabus for one single calculus in single variable. And how we begin the entire discussion. So there are two types of slope. One is called slope between the 2 points, which are any general separation. So in a graph, if I choose 2 points, one at x1, I will just call x, and other which is quite far away, and I will call x plus delta x, a big change. And let's say the dependency is given by the symbolic relation y equals to fx, which means I do not know the exact equation of this graph, but I know that y depends on x. So what fx represents? The vertical height, the height parallel to y-axis, right? So what do you mean by fx graphically? So fx is basically the y coordinate, na? This height. So you can also think of fx as the height from the x-axis. So this point, so this you can either call y or you can call f of x. It's a way of writing. So I will say this as f of x. Now when you go to x plus delta x, what will be the y value? So if the input is this much, the output will be how much, guys? Or if I want to write the output, how I'm going to write? Tell me. So this is the coordinate of this point, 0, fx. What will be the coordinate of this point? Anyone? Tell me. Anyone? Please tell me. This
Sir,
is dependency. Yeah.
0 comma f of x plus delta x.
That's it, because that is the input. So this is the output. Very good. So now imagine if I join this point, I hope you know this name. What we call this line? Line joining the 2 point is called, I mean, a line which passes through at least 2 point of a curve. What we call? Or a line which intersects a graph at 2 or more than 2 point. What we call such a line? Try to recall from the circle chapter.
Secant.
Very good. This is called secant line. Okay. So secant is obtained when you draw a line by joining any 2 point on the graph. Okay. Understood? This is called secant. So now, once you know this is called secant line, can we find the slope of any line? Because we have studied the straight line equation. How to find the slope of a line? Because line will have constant slope. So what will be the slope of this line? Tell me. So tell me the slope of this line. So finding the slope is as good as finding the tan theta, right? So slope is defined as the tan of angle made by the line with respect to positive x-axis. So what is slope? Tan of angle made sorry by the line with positive direction of x-axis. So how to write the slope tan theta? Tell me. Looking at the graph. By looking at the graph, how to write tan theta? So you can choose this triangle. Let's call this triangle as P Q R. So anyone please tell me the answer. How to express this tan theta?
PR by QR.
PR by QR is the right answer. What is PR, by the way? Looking at the y-axis, can we write in some other way? So what is PR representing? What is PR equals to? If you look at the y-axis, it's the difference of which two numbers?
y2 minus y1.
But I haven't written y2 somewhere, right? Anywhere.
Sir, f of x plus delta x
Very good.
minus f of x.
Excellent. Was this difficult to see? Tell me, guys.
No, sir.
So what is QR? If I want to write what is QR,
X plus delta x minus x.
which is
Delta x.
delta x. Excellent. Very good. Don't try to think that calculus is something new. Calculus is your old friend from geometry. It is just like it looks a very new subject, but it is the old friend from geometry. Because if it is something really new, then it's difficult to think about. So how Newton developed this entire calculus? Because most of the credit goes to Newton and Leibniz for developing this entire new branch of mathematics using the old concept of maths. I mean, of course, they never try to create something out of nowhere. So what they introduced was, first of all, a nicer way of writing this complex, I mean, not complex, I would say, this long expression. I mean, he simply shrank that expression into something nice looking symbol. That's it. Okay. So the slope of a secant is simply you choose two random point, you write the difference of the y coordinate, divide by the difference of the x coordinate, and you're done. Okay. And this we can also write as del y by delta x, like this, delta x y by delta x. So all are equivalent expression, tan theta, slope, or this way of writing, or this way of writing, all are similar thing. Okay. And that is the journey begins. Like we are trying to, and now this kind of change is a big change. So the points are very, very far away from each other. Okay. So if someone will ask you what this represents, we say this is the slope of a secant. Okay. This is the slope of a secant. And slope of a secant actually represents the average change. Like on an average, what change you brought into the entire dependent variable when the change in the x was delta x. With the huge change of delta x, how much change we actually achieved for the function which followed this graph. So in physics, the secant actually represents the average change. Or you can say average slope, I would say. Because the graph is not changing as per these 2 points. Graph is changing continuously and distinctly. And then you choose two far away points and you see what is the change between these 2 points. So when you try to find the change between two distinct points, which are quite away from each other, then this is called the average change, or you can say average slope, or you can simply say average. Yeah, I will say average change. So average, how to write this? Average of change of y upon change of x. Okay. Let's keep it average. It is something to do with average. Now, what I said is derivative is a way to say that being at a location x, being at a location x, if I change the x by a really small value, then how the y will respond? How the y will respond? That is the meaning of derivative. So to get the idea of derivative, the point q should be brought as close as possible to the point p. That is the idea. So let me just do a bit. Okay, this is a better. So let's say you are already at a location here. Already you're here. And you are only interested that if I am here called location X, and this is my point P, I am looking for the change when the change is really, really small. So it means instead of choosing the Q here, which we in fact chose earlier, what if the Q starts approaching point P? Oh, I think I reversed the notation. So as the P will start approaching or following this path and try to come closer to the Q, the next slope between the Q and the new location will be, so this is the old slope. So this is the secant when the 2 points are quite far away. The new secant will be like this. You can see the new secant is this one. So this is the old secant. This is the new secant angle. So now this is P dash. Now let's say P dash is coming even closer. And now you can see that the P has come even closer, P double dash. And you can see the slope is, it looks like it is almost getting overlap with the graph itself. So if the P dash will come really close, almost touching the Q, but not Q. And if you draw the secant for those 2 points, which are almost touching each other, so mathematically what it will look like? It will look like a, so what we call this line, which looks like touching the graph at only 1 point, what do we call?
Tangent.
Very good. This is called tangent. So this angle, so what is the tan of, let's call this as your tan theta. So what this tan theta is representing here, I'll make it a tan alpha. Yes, because I want to show the difference of the two angles. So what is tan theta is representing? Slope of a secant or tangent?
Slope of a tangent.
So can we say that tangent is a very, very special case of secant in which the 2 points on the graph are next to each other? Can we say?
Yes.
See, we have no way to find the slope if you give me only 1 point. Can I find the slope with only 1 point? Tell me. Mathematically, is it possible to find the slope with 1 point?
No, sir.
Slope is defined for 2 points. And therefore, slope of a tangent is a very unique situation. It is saying that that line is representing the change in y upon change in x, provided the change is minimum possible change. So if you bring a very small change, then you won't be able to see the two separate points, because those 2 points are almost coinciding. And the secant, even if you try to draw mentally, that is a very good candidate for tangent. Again, I'm saying secant is not tangent. Secant is secant, tangent is tangent. But under the assumption that these 2 points are very close, can we call they are roughly same? Even though there are some difference, can we ignore such differences? Yes or no? Tell me, guys.
Yes, sir.
So there is no mathematical way to get the slope of a tangent. So what we do is we take 2 points which are very close to each other, and by taking such point we actually get the answer. Okay. So in computer, when we try to implement the differentiation, we do the same trick. We take a number, we divide the number into, let's say, 1 lakh parts. So you take a number, let's say 1, you divide it in 1 lakh, and then 1 upon 1 lakh is a very small number, and you keep on feeding that number to the graph, and then you keep on checking the slope. And when mathematically it is very close to 0, let's say after 10 decimal place, if there is no number, we call it almost 0. That is how the machine understands the slope. Of course, machine cannot draw tangent or something like that. Machine only understands number. So the tangent, when you try to draw on a graph, so to draw the tangent at any point is a simple trick. You choose 2 points in the vicinity of that point. So that point and the immediately next point you choose, and you simply join these 2 points, which are not distinct in terms of visual appearance. Conceptually, they are different. And such point, of course, we cannot plot because we never know what is the number next to a number, right? We have discussed this part. And so those 2 points are like a pure concept to the mind. We cannot see those 2 points distinctly, but we know that they are different. Okay. So that's very important. And then the secant of such point becomes tangent, and therefore the derivative, or you can say dy by dx, which we call, is actually representing the slope of that tangent which you draw at x. Okay. Now you can substitute the, let's say if someone is asking that what is the answer at x equals to 1, so you put x equals to 1. What is the answer at x equals to 2, so you put x equals to 2. What is the answer at x equals to 3, so you put x equals to 3. So the idea is finding derivative is like, or finding dy dx is like to understand graphically what will be the tangent. If I don't see the graph, let's say for every function in math there is a graph. So given the graph at a location whose random value is x, if I want to understand the theta made by the tangent at that location, because every point will have infinite, different tangents. So I can say in a graph, every tangent will have different angle, right? So for example, if I shift the x to this location, if this is the new x, then if I try to achieve the tangent at that location, it will look like this, correct? Now, can we say the slope of this tangent is same as the slope of this tangent, the old tangent? Can we say yes or no?
No.
And this slope is, this looks like that given the point P dash, if someone is sitting there, how steeper the graph is. So you can see the green line is more steeper than the blue line, not blue, it's violet, whatever, violet. So which slope is more steeper? Can you check the steepness? Then you check the steepness of P or P dash, or sorry, Q or P dash, Q and P dash. So which slope is more steeper? This or this?
P dash.
P dash. And steepness represents there is a sharp change going to happen at that location. So you bring a small change in X, you will always see a bigger change in Y. Understood? But at Q, what do you see? It is not that steeper, which means the change will not be as much as P dash. Understood? So geometrically, when you're trying to write dy by dx, it always gives you the tan of that angle, which the tangent at that location would have made with a positive x direction. That is the meaning of dy by dx. And because you find the derivative for a general point x, you get a function of x. If you want to find for a given point of x, let's say if you want to know the answer at a, when x is a, so you will only first you assume x, you get the answer, then you put x equals to a to get the desirable answer. So tan theta represents slope of tangent drawn at x equals to x, I mean some random point. And why? Because x is a variable, so every x will have a different value. The number is a different value. So as x will change, the number will also change. Okay. Is this clear?
Yes, sir.
Hello, hello, hello. Okay. So this is how we find the answer. Okay, that's very interesting. What is the benefit? Now you may ask, what is the benefit of learning this derivative? Now the thing is, at this stage, probably you won't be able to use it. You only learn as a tool. So for you, it's just a mathematical tool that we have to learn. And but in reality, we do use in real life, especially when we do the computing. So it has to do with the computer science, you can say, in actual implementation of some mathematical algorithm. I'll just give you some. So let's say if I ask you if y equals to root of x, and if I ask you what is the dy by dx at x equals to 4.09, it's like a very bad situation. Those who know the derivation, you can differentiate, and when you put x equals to 4.09, it's not really nice number. We know it's easy to do it for x equals to 4. I'm looking for the number which is not 4, which is slightly ahead of 4. What does it mean? Let's say this is 4. Let's say this is 4. Am I looking at 4 or at somewhere else? So I'm looking at somewhere else which is very close. So can we say 4.09 is not much ahead? Can we see? So 4.09 is where? You can see here. So between these 2 points, can we think as a straight line equation? Can we say the next point called 4.09 is rather part of the straight line than the graph, actual graph? So what I'll do is I'll ignore the actual graph. What I'll do is I'll find the slope of this line, where at a nice point, which is 4. So let's say you do calculation, you get the slope, you get the tan theta. And then because I know this 4, I know the answer of this is how much? If this is 4, this will be 2. Correct? That's very easy. You know the height. So you know the y, you know the x, and because if you put x equals to 4, we get y. Y equals to under root of 4 means. And because we know these 2 points, so this point will have the coordinate of 4, 2. Can we find the equation of a straight line using the point slope form? Because I know one point and I know the slope. And how you know the slope? So what is the equation of straight line using the point slope form? Tell me, guys. y minus y1 equals to m into x minus x1, isn't it? I hope you remember
Yes, sir.
this. Basically, y minus y1, which is luckily here 2, m is basically dy by dx actually, and x minus x1 is 4. So y I can get by writing 2 plus d by dx x minus 4. Now the benefit is those who, let's say you know the differentiation. So dy by dx will be how much? So I'll tell you the answer. It will be 1 by 2 root x. Let's say, I mean, this is something which you will learn just after some time. Let's say this is the formula. So what is the slope at x equals to 4 value? Because that is easy number to find. The answer is 2 under root 4, which is 1 by 4. Now, what you don't realize that I can attach 1 by 4. And now x minus 4 is the last thing. Now you want to find the y value on a graph. You want to find the y value on a graph at 4.09. So what I'll do is I'll put x equals to 4.09 because I believe that the 4.09 is on the actual graph and 4.09 is also on the straight line. And because the gap is not much, so I can say both answer will be roughly same. That is like approximation. So I can write y equals to, now if I just write here y equals to 2 plus 1 by 4 into x is how much? 4.09 minus 4. And now you can see we have the exact answer 125 into 1209. And I can see just a minute. This is the actual application we will see in future, not now. So right now it's difficult for you to come across. Maybe you can come across also, but you can understand why we use the differentiation, why it is so powerful as a technique. And it is like a, if you understand the straight line better, then you can. And my answer turns out to be y equals to 2.0225. See, I got the answer. And now, just a minute. Now you can do one thing. I got the answer through this some idea of line and the idea of slope. If you substitute x equals to 4.09, how much will get? You can check in the actual expression. Now what you can see here, if you choose this formula to get the y of 4.09, is it difficult? Yes, it is difficult. Without calci, it is really difficult to find the square root of 4.09. Now with the help of calculus, see, I got the answer. Can someone match the answer by writing 4.09 here and then see if it is coming closer or not? Anybody? Just check how close we are with the idea of calculus. You can check with your calci and tell me the answer.
2.0223.
Quite close. You are able to match the answer up to which place? Third place of decimal. That itself is a big achievement. calculus is only meant for calculation. So it's very difficult to realize that to find the square root, people used to use the calculus. It's interesting actually. So anyway, so you will come to that the derivative and all. This formula, the y m is called dy dx, and m represents the slope at one particular location. One particular location. That location you can choose. Okay, and then the y you can find, because the next point is here, and this belongs to the line also, and this belongs to the graph also. Anyway, so we'll come to that later on, don't worry. What is the meaning of tan theta is clear. I hope this is clear. So when two numbers are very close to each other, what we call the slope of secant becomes slope of tangent. So how to represent tan theta mathematically? Any idea? So we know the answer for what? Secant. How to write? So del y by del x we know as f of x plus delta x, f of x whole upon delta x, and this is actually way of writing for the slope of secant, the 2 points which are far away. Under the condition, when I say limit, when the 2 points are not far away, if the delta x is so small that the del y by del x, the delta y by delta x, we can write as limit. I'll put limit on both sides, and I can write this as x plus delta x. Under these situation, this entire notation, Newton said, okay, don't write like this. You can write in a nice way of this. So he introduced dy by dx. The dx means the small change, d for change. The d symbol is for change actually. So dx means change in x, dy means change in y. So dk means change in kinetic, let's say dp, so change in momentum, so you said df, the change in force, dE, change in energy. So in physics, dV, change in velocity. So ds, change in displacement. So you can interpret the d of something. So the symbol is y, which is the dependent variable. D means change in that variable. So that's how we understand. And this we can write as limit the change you bring almost zero. So in mathematics, they don't use the symbol delta h, delta x. What they do is they write delta x as h, and that's fancy for them. So you see a very fancy looking notation in mathematics. They write h tends to 0, x plus h minus f of x upon h. So this is called the differentiation by first principle. What we call? This is the basic. This is how the differentiation actually started. Now you know the formula, but that is not the formula. So what we call is differentiation by first principle. So every formula of differentiation which you see today is actually derived from this particular method. All the rules of differentiation is also derived from the same, this method. So all the formula which you see, I mean, that can be derived actually. So those who have already finished this part in maths, I mean, you know that this is the mathematical way of writing. So to find the dy by dx of any function, what you have to use is this technique. You have to take, first of all, what you do? You take 2 point h distance away, you find the secant, slope of the secant, and then you take the limiting case, you say that this h is very small, and then this automatically becomes this tangent, and so you get the answer dy by dx. That's very simple. You start with the secant idea because you know this is easy. Once you get this idea, then you take h tends to 0, and then eventually you come to something called dy by dx as a formula. So geometrically, dy by dx represents slope of tangent drawn to the graph. Which graph? So because it is not always possible to draw the graph, so sometimes we only see in terms of as a formula. So we'll come to that very soon. So we'll start with something very basic, like if y equals to x to the power n. So x to the power n is what? N is constant and x is variable. So whenever you see a pattern like this, when the base is variable, so any format in which the base is variable, power is constant. Or if we have the combination of such terms, if you have some combination of plus minus and again similar term, variable, power constant, and so on. Anything which we represent in this format, we call it algebraic function. So there are three things that you will face because that is confusing for many students who learn maths for first time. So we can have something called constant power base, power variable. What we call this? If you remember last lecture, constant power variable. What we call? What we call this kind of function?
Exponential.
Exponential function. Very good. And the last is something very complex, which is like variable to the power variable. Like example, x power x. So of course there is no name to it. You cannot call any by name. So this is something you can say transcendental function. I think. I mean, maybe I'm not sure about it. What is the exact name for this? But this does not fall in the category of algebraic or exponential, and therefore the first step of learning differentiation is being able to distinguish between various notational meaning actually. So this is called the algebraic function. So we have the base to the power, okay, and let's say this will as n will if I choose n equals to 1, it is straight line. If I choose n equals to 2, it's quadratic. If I choose n equals to 3, it's cubic. So n can have any value, which I don't know. But the question is, can we find dy by dx from scratch? So if you are okay, the first timer in mathematics, the way we proceed is simple. No matter which function is given to you, I always do this graph. So when I was a student like you, this was my method of solving question. So for any function, I used to draw this same graph every time, because that is the most convenient graph to understand. I mean, of course, this is not the graph which you will actually see, but there is no harm in drawing some random graph, because eventually we are not going to use the graph, we are going to use the idea. What is the next step? And then what I want is that you all must keep on writing along with me. So please take your pen and paper and start writing the way I'm doing. So you first assume this. Let's proceed one by one. I'll show you step by step how we proceed actually. This part is done. So are
Yes,
you
sir,
with
done.
me till here? Okay, fine, very good. So if you all are with me up to here, the next step is choose some point and call it x. Are you all done?
Yes, sir.
Okay. Next step is take another point which is slightly away and name it x plus h. You all are done?
Yes, sir.
This point will be f of x and this point will be f of x plus h, right? Okay, I'm not writing 0 comma. And the next step is find the slope of secant. So you write del y by del x. So del y by del x is how much? Write down secant. Hello, hello, hello.
Yes, sir. F of x plus h minus f of x.
Proceed with me, please, everyone. So now x plus h. What is fx, by the way? So here f of x given to you is x power n. So what will be x plus h? Tell me. If input is x, answer is x power n. So if the input is x plus h, what will the output?
X plus h whole power n.
Very good, excellent. Okay, at least Siddhant is with me. Please, everyone, join me. So what should I write here? X plus h power n minus x power n, correct? So far, so good. Tell me if you're till, I mean, if you're here till with me, then probably we are in the right track. So you all are with me till here?
Yes, sir.
Divide by h. See, I taught this entire calculus this way to a class 8th student long time back, and he finished the entire calculus from math book completely using this first principle without knowing the formula. Anyway, he's going to be the future topper from Mumbai, and you will hear the name. Okay. So now this is x plus h power n minus x power n upon h. It is like everything proceed in a very logical fashion. You are not supposed to mug up anything. It's very logical. Now to find the derivative, what is the condition? To find dy by dx, what we do? We write limit. The change must be very small. Then the del y by del x automatically becomes the dy by dx. This is the idea, isn't it? Yes or no? Tell me.
Yes, sir.
So we can write limit h tends to 0. If I put h equals to exactly 10, exactly 0 right now, this will be in which state? Defined or undefined?
Not defined.
Not defined. So it is undefined state, right? So definitely I cannot put h equals to 0 right now. So the logical step is, can we convert into the defined states? And see, here we have the binomial expansion. If you remember the binomial expansion, in C0 a power n and like this, yeah. Anyone remembers the binomial expansion formula? Okay, anyone remembers the binomial approximation formula? 1 plus x power n is roughly equals to 1 plus nx when mod of x is very, very small than 1. Anyone remember this one? No. No one.
I remember.
Okay, very good. So I want to convert this into 1 plus x power format, and to convert 1 plus x, I will take x common outside. And that's a logical choice because I want to make the fraction. So h is anyway fraction, h is very small, but when we write limit h tends to 0, x plus, there are many ways of solving, but I'll just give you the simplest way of solving. Can I write I mean, of course, there's no need of writing a limit h tends to 0 always, but it's a good practice. If I take x outside, what will get? X power n 1 plus h by x power n. So x is some random location on a graph, but h is really small. H is as good as 0. So any number, so something close to 0 upon any number is anyway close to 0. And therefore, this is the suitable candidate for the binomial approximation. So you can just write, even if you don't know, that's not required. 1 plus some fraction which is very small, power n is 1 plus power into fraction. That's it. Remember this much. That's sufficient. Or what else you can remember? So 1 plus x power expansion. I'll tell you the expansion once again. It is, what was that? 1 plus nx upon factorial 1 plus n into n minus 1 by factorial 2 into x square plus n into n minus 1 into n minus 2 upon factorial 3 into x cube and dot 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 dot. You can write like this also. Which one you want to prefer? That's up to you. This is true when x is like a small number. So which one you want to choose? Okay, I'll choose this one, this way of writing for the first time. So this we can write as 1 plus h by x power nothing. This is nx, right? Nx. Nx plus, and upon factorial 1 is 1. So that's, we can leave. The next one will be n into n minus 1 upon factorial 2 into x square, which is h by x all square. Okay, well, that's fine. And then I'll get minus x power n. Okay, minus x power n and upon h. And I hope you can see something gets cancelled. The 1 gets cancelled, right? Do you realize this? Maybe. So we have x power n, and if you look the other terms, can I take common? This is why this is written when. So what we can take common from a remaining term? If once you cancel the 1, if you expand, you will get cancelled. So what I can take common from the remaining term? H by x we can take common. Correct? So what I will left with? 1 plus, and because I have taken h minus h by x common, so I will get h by x power 1 because 2 minus 1. The next will be no need to write further upon h. So what you can see that because h is tending to 0, so this h you can cancel with this h. I missed something. It was okay. It was n here. Okay, I thought it's. I can take n common also. So anyway, let's leave it n here. That's fine. So now you can see that because h is non-zero number, I can cancel it. So what we're left with, guys? Tell me. X power n minus 1 into n plus something which is function of h. Now, if I put right now h equals to 0, what will happen? All these terms will vanish, isn't it? Do you realize this? Every term beyond this is a function of h. And if you put exactly h equals to 0 now, first of all, it is in a defined state. And putting h equals to 0 will just make every other term 0, isn't it?
Yes, sir.
And therefore, what we're left with? N x n minus 1. Now you may call this as a formula, but this is not a formula. This is like derivative which we actually get if we do the definition. Okay, if we proceed using the definition of dy by dx, the way it was defined. So of course, to find the complex derivative, one should be master of limit, how to manipulate the limit. At least you just master of this part. So in fact, if you remember all the first two terms, that is sufficient. So the rule is like whenever I get a binomial, I try to convert it into one plus some fraction. And that idea is so powerful that in the entire physics, you will again see that kind of approximation used very extensively in many chapters. So like you have chapters like a resistance calculation in which we use this idea of binomial. We have chapter like a thermal expansion, which we again use the binomial approximation a lot actually. We have chapter like wave optics in class 12. Again, there we use the binomial approximation a lot. So you will come across a variety of physics chapter where the binomial approximation is the way to go. So realizing that under what condition, what I'm capable of using, what are my limitation, what are my application domain of certain mathematical formula, that is going to be really powerful to give you the better edge in terms of numerical solving compared to the other. So now, in generally, when we study the calculus for the first time, it is given as a formula. Okay. But I'll say is that you start doing as a limit. I mean, of course, at least do few questions and you will realize that, okay, it's really interesting. So dy by dx turns out to be nx. And it's so easy to remember. It's like the power, the base to the power minus 1. So you reduce the power and what you reduce, you multiply. So that's like a formula. This is called the power rule. Generally written in text, power rule. So for any variable to the power constant, this is applicable. Of course, you cannot try to use it for I have seen that many students use for this also. That x minus 1. That's ridiculous. We can't use. Many students write for this also. X to x minus 1. This is again totally in a domain which is not part of this rule. So you cannot use warning. Okay, I like warning with a red sign. So when you're not able to use, when the base is variable and power is variable also, we cannot use. When base is constant, power is variable, again we cannot use. When we can use this formula, tell me. Only when we should use this formula, tell me.
When
Guys.
base is variable and power is constant.
Very good. So if you remember this simple thing, probably you won't make any mistake in using it. So let's do some practice. Now, once you know the formula, we use as a formula. It's like the other way of saying it. Before I use this is the formula, I'll I'll derive one more. Let's say if I say if y is sine x, and I hope you all are aware that the dy by dx is how much? Okay, so you don't know. This is equals to cos x. You will get. Can we derive from again the basic the same rule? So now I'm going to write. No, I will not write. Please, you all try. Use the approximation that sine of x is very small, then it is or equals to x. Cos of very small is 1. Hopefully we get the answer. So please everyone try it out and tell me are you getting or not. Everyone. Have you all started? Please tell me. Use the first principle to get me the answer. Garv, are you writing?
Yes, sir.
Give me the answer right now. So anyone got the answer? So tell me the first line which you wrote here. What you wrote here? Limit h tends to 0. Then what is the next step? Next step? Hello, hello, hello.
Sine of x plus delta x minus
Yeah.
sine x upon delta x.
Very good. Now this is sine of a plus b formula, which we know how to expand, right?
Yes, sir.
So what we can write? Sine
Sine
a
x
plus b.
cos.
Sine a cos b plus cos x okay. So what you can see that for a small angle, cos 0 is 1, but sine 0 is angle, right? So we can write actually this as, so sine of x and cos of h we can write as what? Cos 0 roughly. Cos of 0 is what? 1. Get that. Then the answer is cos of x into, I'll taking it outside, limit h tends to 0, sine of h upon h. What is the answer for this? Again 1. Anyway, we know this answer. You can write h by h, which is 1. So your final answer is cos of x. Understood? So dy by dx of, when we find the dy by dx, when y is sin x, dy by dx when y is sin x is cos x. So again, I will not keep on deriving, but if you are interested, you can go on deriving all the other formulas using this simple trick. So in physics or maths, especially I will say physics, there are certain formula that you must know or remember or understand. There's certain that you must know. So those are like basic. The rest, keep on referring to maths book if you need some time. So so what you can add is, so we're going to study the same thing, dy by dx. So dy by dx is like a slope of tangent, but we are going to learn the dy by dx not here. We are going to learn something called d by dx as an operator. So now we are trying to come out of the geometrical meaning, which we have done already, to a different meaning called operator mathematics or operator based ideas. So dy by dx is like an operator which operates on some function which you put here. So there is a placeholder here, like a box, and whatever you put as an input in this box, this dy by dx operator will operate on the box and will give you some output. So we can again do the box diagram. So we have a box with operator dy by dx. We have some input. Here the input will be function itself. So here we take the input. And when this input is given to this operator, it gives you some output. Now in the language of mathematics, we write this kind of output as f dash x, which is easy way of writing. there are many ways of writing. So if you call this y equals to fx, sometimes we also call this as y dash. So there are many ways of writing like this. So operator is like some mathematical symbols. You can think as a one concrete symbol. So d by dx is now one unique symbol or notation. And under this operator, if something is given as an input, it spits out some output. And those outputs are predefined. I mean, of course, can be derived, but you think that is predefined. In that way, you can think of. So, for example, if x to the power n is given to this operator called dy dx, what it will throw out? Tell me, guys, what it will give us?
n x raised to n minus 1.
Excellent. Very good. So x to the power n will throw you n x n minus 1. That is like an output, and you can think this is the operator. So while writing the formula, you can think this way. Don't read this dy by dx, read like d by dx of y. So how to write now? Reread this same thing. D by dx of y. That's the meaning of this. So d by dx is an operator which you operate on a variable called y, which is of course function of x. Now what you need to actually understand, the differentiation is only possible when there is a dependency. Let's say if y does not depend on y, if, does not depend on x, if y does not depend on y, on x. So let's say you're trying to make a sharbat. So you take a glass, you put some cold water, you add some flavor, and you get the sharbat. You add sugar to sharbat, that the sweetness will increase. Now your glass, your water, and your sugar, if all come together, then I can say the sweetness will depend on all this ingredient. But if I add more sugar to your friend's glass, will it affect my glass taste?
No.
Of course not. Similarly, if y does not depend on x, now whatever change you bring to x, what will happen to y?
No
It is
change.
like you're adding the sugar to the other glass and you're expecting the change of taste in your glass. Is it going to be possible? So the answer is no, it's not possible. So therefore, the differentiation d by dx will operate on those functions which have a relationship with that variable which you are trying to bring the change in. Okay. So if I want to find d by, let's say d sine, then the function here must have the dependence on which variable? Because the d by d sine is you're trying to bring change in this kind of variable. Then this derivative will only work if the function having dependency on this variable. Is this clear? If I ask you d by d box, I will just bring some box. Now the box represents some sort of unknown variable. So who will work on the or this derivative will work on the function only when the function also depends on the similar box, isn't it? Are you getting this idea? Yes or no?
Yes, sir.
So if I say d by d of rat, then this will operate on which variable? I'm changing the rat. So the output must be depending on the rat. Then only we can define the differentiation, isn't it? So can I write this f must be function of what? X must be function of
Rat.
only rat. So when we learn this as an operator, then you have to understand the dependency part, that only similar dependency can be differentiated. Okay. So why this is very important. So in the topic of chain rule, this will be very powerful. So let's say if you really understand this part, you will understand something more. So if I want to differentiate can we differentiate? Now the base is here what, variable or constant? What is the base here? Hello, hello. The base is what, variable or constant?
Variable.
Power is
Constant.
exactly. So actually we can use the power rule, but the problem is the operator is only good with when the base is having X notation. But here the base is having a different notation. So whenever there is a mismatch, but luckily eventually depends. I know there is a mismatch, but it depends. So then you will be introduced to a concept of chain rule, in which we bring a new variable, which is like a matching variable. Now this looks really cool because here we have variable power n and the d by d of same variable. Now this is the format of x power n because x is input. X never represents x actually. X represents some input. So the way to read is not the way you read. It is d by d of chosen input. I'll just write. Or you can say input. And input to the power n. So the formula is n into whatever input into n minus 1. This is how we read the d by sorry, d by dx of x power n. So if you know the basic formula, that this is the formula which you know. So when you say that d by dx of x power n is nx n minus 1, how to read this? Is d by d input of input power n is n into input into n minus 1. That is how we read it. So you have to read like this. If you know this, let's say you know this formula somehow. So if I ask you d by now, can we say this is the formula of power rule? Yes or no? If you think as a black box, if you look at e power x as a black box, so this is like a d by d box of black box power 2, isn't it? This is like if I choose the e power x as entirely single input. If my input is e power x, then is it matching this format? Yes or no? Is this matching?
Yes.
Yes, sir.
And if it is matching, then can we use the formula? The answer is yes. So what will be the answer for here?
2e to the power x.
Simple. It's so simple answer. Similarly, okay, here what I did was I introduced sin x which was not there. Because it is introduced, I have to cancel the effect. And then I'll bring the dx again back. Now both are same thing because the extra term I have written in the numerator and in the denominator, and therefore I haven't altered the actual expression. But the good thing is this is a perfect formula which we know. Which formula is this? D by d input of input power n. And what was the answer for this, if you remember?
N into sin x to the power n minus 1.
Excellent. And differentiation of sin x we know already from the previous discussion. So what was the differentiation of sin x, guys? Tell me.
Cos x.
So later on, I will learn this is called the chain rule of differentiation. Again, the problem is most of the students think x as a x actually. That's the problem. Don't think x. Whenever you read a formula, read as an input. I'll tell you how to read every other formula. Just 1 minute. Okay, so I'll come to back this again after some time, but this is just a glimpse that how to read the formula. It's a very so if someone is writing, let's say if I give you formula d by dx of sin x is cos x. How to read this formula? D by d input of sine of similar input will be cos of input. And if you read this way, you will never get confused. It's very simple. Every formula which you read should be read in this fashion. So when you write the formula for the first time, then the x is not a variable. X is an input actually. And you have to learn that how to do this. And once you understand this part, it's very easy. Let's see if I want to write d by e power x of sine of e power x. What will be the answer, guys? Tell me.
Cos e raised to x.
Excellent. It's very easy. It's like one should not be disturbed by this way of writing. So if I write d by d of ln x of sine of ln x, it should not disturb you. What is this answer? So d by d input of sine of similar input is what is cos of the input? So what will be the answer, guys? Tell me. Hello.
Cos ln x.
So why are you scared to say this is correct? These are the symbolic notation. I mean, the way one should remember the differentiation formula is in terms of input, not in terms of formula. Don't see d by dx and x, you think x is x. X is a very shallow, you can say, object in which you can insert anything. X is some sort of a packet or a container. You can say this is container. So you always think as a x as a container. So d by d of some arbitrary container, and then you have well-defined function. This is sine of container will give you the cos of container. That's how we think, like container or box or whatever, dabba. So when you say d by dx of x power n, can you see the input part? Of course, you can see the input part, right? So match this input and match this input. You will realize that what is input. Whatever we write here is the input. Okay. And what was the answer? So when d by dx will operate on x power n, what it gives?
N into x raised to n minus 1.
Very. So d by d dabba of dabba power 5 will be how much?
Five box 4.
Excellent. So don't read differentiation as a x. X is like a container or some sort of placeholder, we call it. So when we study as a operator, it means we think d by dx is some sort of machine in which you put something, it spits out something new. Okay. So what are the formula that we must remember? So the two formula I gave. So I'll just make a table. So I'll write an input. So if the input is here, so we call the input as f of x, or and then we get output, which is d by dx of the input given. Okay. So if you give the input as x power n, which means if fx is x power n, the output will get is nx n minus 1. So if you give input as sorry, sin x, what will get here? Tell me.
Cos x.
Cos x. Sorry. If you could give cos x, then oh, we don't know. This is minus sin x. And why minus will come? I can tell you the logical way of thinking. When you try to derive from the first principle, what you write? Cos of x plus h minus cos of x upon h, and we know that cos of a plus b is cos a cos b minus sin a sin b. And therefore the minus will come. If you simplify, you will get the minus answer. So when you differentiate cos, you will get a minus sign. Okay. So what else we need to know? Every formula. If it's 10x, then so the answer is, if you have to derive it, of course, it will become sec of square x. So sec x square, you can say. If it is a cot x, then the answer is minus cosec square x. If it is sec x, then the answer is sec of x into tan of x. And if it is cosec x, then it is minus cosec x into cot x. So many formula. The integration is ln x.
1 by x.
Yeah, it's very famous, 1 by x. And then e power x. E power x is what? Same answer. Luckily, the e power x, even if you differentiate it, the tangent will also follow the similar graph. Okay. All can be proved using simple binomial expression. Okay. So some more, in fact, this is sufficient for us. And other we can understand after learning the chain rule. So what else? Like if I continue with, so if it is a power x, not is exponential, but it is not it is not the e power x. So what will happen? So it will give you the answer a power x ln, and I'll prove it. Don't worry, it's not very difficult. Sorry. If it is sine inverse x, it will give you 1 upon 1 minus x square. If it is cos inverse x, it will give you minus 1 upon 1 minus x square. And rest you can prove easily than mugging up. It's easy to prove. Okay. So we'll use this basic formula to first practice some easy questions. Okay. So let's practice now. So if I give you x power 3, so what will be the d by dx of this x power 3?
Three x square.
So if it is x power 4, And there is a simple way of writing. I mean, this is not a, I don't use this. I mean, you can write in short dash, which means what is the differentiation of this number, this variable. By default, we write d by dx only. This is a short notation. So what will the answer,
4x
guys? Yeah.
cube.
4x cube.
Very good. So now if I give you root x, what is the answer now? So now the power
1
is fraction.
by 2 to the power minus 1 by 2.
So it is like this. So which is again minus becomes, if you can shift the position, it will be in the denominator, x power half. And what is x power half means? Root x. Correct? So 1 by 2 is basically root x. Okay, so what will be the answer of this? I hope you know the meaning of this. How much, guys?
So 1 by
1
3
by 3 into
cube root of
x to the
x
power
square.
Yeah, x power
2 by 3.
plus or minus.
Minus 2 by 3.
So it is 1 by 3 minus 1, right? Power minus 1. Anyway, you can leave like this. So generally the powers are interesting. What is the differentiation of this?
-1.
Minus 1. What is the power here?
LNA or something.
Don't
So
get
minus 1
distracted.
upon x square.
Minus 1 upon x square. The power is minus 1. So what is the formula? N x n minus 1. So minus 1 is minus 2. No?
Yes.
So when we write something like this, 2x cube, what is the answer? Tell me. Okay, sorry. As of now, just write x cube.
So minus 3 upon x raised to 4.
Very good. Minus 3 upon x power 4. So when it is in a fraction, when it is inverse, then power will increase and the power also gets multiplied here. So you can, with practice, will understand. You can directly answer. What is the answer for this? Quickly, without solving. See the pattern.
Minus 4 by x to the power 5.
Very
Minus 5 upon x raised to 5.
Minus?
X raised to minus 6 upon x raised to 7.
Very
Minus 13 by x to the power 14.
Very good.
So minus 3 upon 2 into x raised to minus 5 by 2.
Like this.
Yes.
I think this is the right answer. Very good. So how many of you got this answer? Raise your hand. Very good. Okay. 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 Christian, sir, you got the answer?
No, sir.
Why? Is it so difficult? First of all, you have to write in single power of x. No? So how we write x root x as x power 3/2, right? So what we do generally, we write the power with minus sign, and we increase the power by 1, right? So 3/2 plus 1 is 5. Okay. So if I give you like this x square root x, now
Minus 1 by x square.
minus, first of all, convert into x power something.
So minus 5/2 upon x raised to 7/2.
Excellent. So I think this is the first practice. I hope this is not difficult. Or is it difficult? I don't think. Okay, so let's use some other one. Some rules. We'll study first some rules, then we'll come back to again solving problems. So if we talk about something called addition, okay, I'll start with multiplication. If a function let's say if you insert any function here, what you get here? You get some derivative. Let's represent by f dash x. The question is, if I differentiate or if I apply the operator on number, something like this, a constant multiplied to the function, the rule is simple. The constant will be of no use. We can just bring it out of the operator, and you simply multiply this outside, and you can apply the operator the way you apply for the function, and the answer will be the constant into the operator. So that's simple. So whenever you have any constant multiplied, you just throw it out, okay, and solve the way you want. Okay. Now, if you modify the input, okay, so the input is x, and if I tweak the input, so let's say if I know that if I differentiate f of x, my answer will be f dash x. Let's call this is the answer. So you know the answer is f dash x, and you know the input is fx. What is both? I don't know as of now, but let's say this is the answer. So if I tweak the x on the input side by a constant a, it means if everywhere if I replace the x by ax, then in such case the a becomes product, and your answer will be similar to what you got earlier. So write the same answer, assuming there is no effect of x. In the end, simply multiply with the a part. Again, I'll prove this in the chain rule part. But it's good to remember this as a formula also. So what we are doing, once you tweak the input, if you scale the input, this is called scaling. So when we write a into x, it means I'm trying to modify the input the way we did for the in vectors. So when we scale the input by some factor, so a is called scaling factor. What do you call? Here a is the and what does it mean? If you scale the factor, scale the input, the output also gets scaled. That's the meaning. So when we scale the input, the output also gets scaled. Okay, by the same factor. Understood? Maybe not. Maybe yes. So how many have understood this method? Just remember this. Proof is very simple, trivial, but it's good to know this as answer. That when we scale the input, so you know the standard formula, and from that standard formula we scale the input by some constant factor. The output gets scaled by the similar factor. I hope this is easy to remember, or is it difficult? Is it difficult, guys? Tell me. Raise your hand if it is difficult. So let's say you know the answer that x power n, if I differentiate, I will get nx n minus 1. So here the input is x. What if I write kx, or I write kx power n, and then you are trying to find the derivative of this. So the input was x. Now the input is what? Kx. Okay. So the rule says that you first simply differentiate, assuming this entire input as one entity. You can differentiate assuming this as one object, which is like input. And when you scale a input, the function will not change. It is still algebraic function, still having similar features. So what will you answer? N input n minus 1. What is the change here? At the end of the answer, we have to scale the input again. Sorry, scale the output again. So what is the scaling factor here? Okay. Okay, maybe this is difficult. Let's see if I write 3x whole square. So here are two things which I have done. First, this 3 is the simply product. You are just multiplying with the constant. So I'm using the first rule. So this 3 can be taken outside the rule of differentiation. So I can write 3. And then I'm left with only this factor. Here what is happening? The 3 into x whole square. So 3 is getting multiplied. So what will the answer, guys? Tell me. So you differentiate assuming that 3x is the input. So what is the answer? 2 into 3x power 1. But at the end of this entire calculation, what will do? We will multiply with the factor which is scaled the input, which is 3 here. Oh, it seems like very difficult. Eh? So those who got confused, raise your hand. Confused?
Sir, understood.
Anyone finding it difficult? Tell me. Hello, hello, hello.
No difficulty, sir.
So now this answer turns out to be 3 power. This is power. This is not dash. This is power. Answer is 339 to 8 4x. Look at the other way of writing. This way you could have written as 3 square is 927 x square dash, and then I can take 27 outside, and this is x square dash, which is simply
54x.
54. It's the same thing. I'm just trying to show the meaning of this. Now, there are two things that you need to understand: the scaling and shifting. So imagine we have the mule, and the groom is on the mule, and then, so first of all, okay, I cannot draw it. You can understand this. I'm very poor with drawing. I think it looks something really weird. Nevertheless, so first of all, you climb the mule. So this is called climbing is called shifting upward, and then mule walks. This is called translation. This is called shift, or we can say vertical shift. This is called the horizontal shift. So mathematically, every mathematical function is a graph, and therefore every process we can see as a shift actually. Okay. So there are two types of shift. One is called the scaling, other is called the shifting, and then the other is called translating actually. So it's difficult as of now, but you can understand that if I say y equals to fx represents a graph, okay, then y equals to f of ax represents scaling. It's called scaling. Now, what is the meaning of scaling? So scaling means the graph will either expand or shrink. Okay. So to give you a simple example, I'll just take a different example. So if I draw any graph, let's say this is the graph. If this is representing y equals to fx, then when you change the input variable, then this will only either shrink the graph or expand the graph. That is the meaning of scaling. So this is the y equals to ax So when it will expand, if a is more than 1, it will shrink. If it is a is less than 1, so here a is a fraction. If the a is a fraction, it will expand. If a is more than 1, it will expand. That's the meaning actually. And if I say this is the graph, this is called, okay, shrink, expand. Now if I write something like this, let's write x minus I'll write like this, a x minus. So when you replace x by a difference of some number, you write x as of instead of x, you write x minus b. The meaning is this is called translation. So you can think this way. If it is x and if it is x minus b, what is the difference? If you put x equals to 0, you will get 0. When this will be 0, tell me. What value of x will make this term 0?
B.
Exactly. If you put x equals to b, this will be 0. So b is called the translational value. So it means the origin has translated towards b direction. So it's somewhere here. So if this is f of x, then this is called f of x minus b. And if you go left, then this is called f of x plus b. Because now this will be 0 when x is minus b. That's why what you write with plus or minus will tell you the translation part, whether the graph is going to be right or left. And the last is called the vertical shift. So if you have any function and if you add beyond the function something here, if c is positive, it will shift upward. So this is called the vertical shift. This is called the horizontal shift. This is the shrink or expand. This is the actual function. So if you know these meaning in function, probably you can understand or read any question with ease. And this is the basis of something called a graph, how to plot the graph. Okay, so what I'm trying to say, if I do all, so I can write if x, we replace the input as a into x minus b plus c. I'm doing everything. So what this a represents? Scaling. What this b represents? Horizontal shift. What this c represents? Oh no, not c. C is not there because c comes with function actually. Yes. I'll remove this part. And if I write the f of a of x minus b, and if I write now c here, then this entire graph is now shifted by c. This is called the vertical shift. Now this is called vertical shift. Okay. Now why I'm saying this? Because whether the given graph is similar to the old graph or not, that's easy to understand. So the benefit is what is the benefit? Look at this. Let's say you know that fx is x square, but that's the easiest example to understand. So what will be the shape of x square? So I hope you can recall this will be something like this. This is called the graph of fx equals to x square. If someone will write that f of x is, if I write something like x minus 2 whole square. So is it representing similar graph or different graph? It is representing the same graph. The only difference between these two graphs is the right graph will shift in which direction? Right or left or up or down? Tell me guys. I have changed the input by x minus 2. Now where is the origin now? For the right graph, the origin is at x equals to, or think this way, like for what value of x this term will be 0?
2.
Which means this represents the same graph which is shifted by 2 units towards right. That's called translation. So the shape will not get affected, only it will shift actually. This is the only difference. This is 2. Okay. And if I add next graph, if I add fx equals to x minus 2 whole square plus 2, what does it mean? This means what? Now the graph will translate horizontally and will also shift vertically by 2 units, right? So the origin, the vertex will shift by yet 2 units and will also lift by 2 units. This is also. So the new graph will be something like this. And nothing happens to the shape. Shape remains same. So what I'm trying to explain is that any linear combination of input will play the role of shifting, translating, but will never affect the graph in its shape. Okay. At max, it can contract or expand, but the overall property will remain same. It is not like the parabola will become ellipse or ellipse will become circle or circle will become something else. Ellipse remains ellipse, parabola will be parabola. So the category or the family which they belongs to will remain same. So what is I'm trying to convey here? A message. The message is very loud and clear. That in any function, if the input is modified by either scaling or adding some constant, so this entire term of writing we call linear combination of input. Because the power of input I have preserved. It is 1 here, it is 1. So when you replace the input by not altering the power, rather by scaling or shifting, so this is called the linear combination of input. Linear combination of input. So whenever you do such kind of manipulation in which the input do not appear as very simple, it appeared with some numbers together. In such case, the formula which you studied will remain intact. Okay. So what does it mean is this: if you know that this, when given to the operator, it gives you this value, then if I feed the input by modifying using something like a linear combination, so I multiply and I add some constant, and if this kind of input is fed to this operator again, the output will not be surprising. It will be similar to what you got, with only one difference, that the scaling factor must be multiplied here. That's the only thing that you have to be careful about. So this A will match here. And if you remember this part, then most of the question you can solve with ease without getting confused. So just remember this trick, which is very helpful. So let's say, what is the d by dx of sin x? Once again, what is the answer, guys? Hello.
Cos x.
So d by dx of sin 3x will be how much? See, I am altering the input now. The x I am replacing by 3x. I'm scaling it. So what was the result of scaling? So it will be cos of the overall input, but because you have scaled the input, what will happen here? The answer will get scaled. Understood? Yes or
Yes,
no?
sir.
So if I give you something like this, sine d by dx of sine of 3x plus 5, the 5 will play no role because it's simply constant. 5 is not used to scale something, it's just a constant. So your answer will be what? Can you guess?
3 cos 3x plus 5.
Very good. 3 cos 3x plus. So the input will be input will go there, and the the scaling factor will come outside. So that's how we remember the answer. And the benefit of this is, let's say if I ask you d by dx of x power n, what is the answer?
nx to the power n minus 1.
So if I ask you d by dx of 3x plus 5 power 2022, what will the answer? You can forget about the 3 and 5, think like x power n, because we are replacing x by the linear combination, so it is still x. You can treat as x, and therefore the formula will be same. What we can write here? Anyone?
2022 into 3x plus 5 to the power 2021.
That's it. Something else we are missing? The scaling, you have to multiply with the scaling
Into
factor.
3.
Very good. Is this clear, guys? Have you understood this? Yes or no?
Yes, sir.
So if I write something like this, y equals to a sine omega t, and we will come to know what is I'm asking. Find dy by dt. What is my input here? What is the input here, guys? How to check the input? Is the input part clear? Now I have replaced x by a new input t. The method remains same. What we read is as an input. We don't read as x. X is just a name for the placeholder. And anything which did not include t, we can call as a constant. So this may be like overwhelming at first, but if you look carefully, because our variable is t, as you can see here. So whatever you see apart from t as a symbol will be the constant. So what a represents, guys? Some constant. What omega represents?
Variable.
How omega is variable? It is constant. Our variable is here.
Yes, sir.
The variable is t only. So anything apart from t will be what?
Constant.
Constant. So tell me the answer. What will be the answer? What you multiply outside remains same, no? So as per the first rule, every constant which we multiply to the function will be out of the scope. So this a we can take it out because it is not a variable. So this is as good as writing a multiplied with d by dt of sine omega t. And what will be the differentiation of sine of something? You can check the dabba. The dabba is t and it is t was just one scaling factor is what is the scaling factor here, by the way?
W.
W, which is called omega in Greek symbol. It's a Greek symbol we call omega. So what will be our answer? Tell me, guys.
Sir, A omega cos omega t.
Excellent. So there is always a difference from physics and maths. So you have to be very careful that when you use in physics, you have to read even more than maths. In maths, it's very simple: y, x, and done. In physics, it is never y and x. That's the problem. So if I write y equals to a cos omega t minus kx. Can you tell me the answer of del y by del t and del y by del x? Tell me these two answers. Now you can understand It is a dependent variable and it depends on two variables we call t and x. So now we have two types of ingredient. And you know the rule of partial derivative. What is the partial derivative rule? When you take t as a variable, then everything else will be constant except t. And when you take x as a variable, then everything else will be constant except x. So tell me these two answers. Let me see if you have really understood the concept of differentiation. Take
Can
your
you show
time.
that input output slide for one second?
Yeah, you have to think as input and output. And when you, because it's a partial derivative, so at one time only one will be variable, the rest will be acting as something constant, B or C or something. So tell me the answer. If you can do this, it means you have really understood the meaning of input, output, scaling, constant, and so on. This is the sigma rule of differentiation for beginners.
So for the k constant, do we have to take the minus sign in consideration?
Yeah, of course, you have to take it. Everything with, because everything apart from that will become constant. So when you differentiate with t, so the first part is variable here. This is number, this is number, these are numbers. So think that. What is the differentiation of cos? First, remember that answer.
Minus
Minus
sign.
I.
So minus sign. So if this first part is whatever you differentiate, cos of whatever is minus sign. So a minus a will be there and sign will be there and everything else will be there. Now you have to only think of scaling factor. This part I'm going to get it for sure. Now when you differentiate with t, what is the scaling factor? For t differentiation, what is the scaling factor?
Omega.
Very. So So this is your answer, del y by del x. So the del y by del t comes out to be minus a omega sine omega t minus kx. Can you now do it for the other part, the del y by del x? Tell me.
Yes, Siddhant.
So what is the answer now?
A k sine omega t minus kx.
Yeah. So ak will come and rest will be same, right? And it will come plus because minus k will come outside, right? The factor is now
Yes, sir.
minus k. It's not k. Okay. So I mean, really, truly tell me, like, how many of you are able to do this? So that is the first thing. Like in physics, this is very common. Raise your hand if you have, or if you have been able to do this. Number one, two. Okay, so rest of you guys, please do practice. Garv, can you show me the other question if I tell you?
What, sir?
I'm going to give you the next question. Tell me the answer.
Okay.
So if I give you the question y equals to, okay, just confuse everyone. Ln ax plus bz. So basically here y is a function of x and z. So you know that the variables are x and z. Everything else is constant. So what is the answer for del y by del x and del y by del z? Just tell me the answer quickly. I hope you know the answer for differentiation of ln x. What is the answer?
1 by
1 by x.
Yeah, so I think that is sufficient knowledge. If you know that answer, it means you can do this answer. Please go ahead and tell me the answer. It's pretty easy. You can treat the entire bracket as one box. And of course, the phi symbol will be constant, so we can take it.
So can I leave now? I have my class in
Yeah,
4
yeah.
minutes.
Yes, you can leave. I think many will have class at 9 p.m. Yeah. So this is the last question. Okay, now let me just give the answer. Okay. So first of all, ln of whatever, this is called whatever. You can just make a box. So ln of whatever is 1 by whatever. So don't worry about this. And the phi is the function, you can just write as it. When you differentiate with x, then only x coefficient I will take care. So which is a. So like, and the moment you do z, it will become b. That's it. Nothing was difficult. Okay. So we'll continue this differentiation. Don't worry, we'll go much deeper, and you will be able to finish almost 70% of differentiation or 80% from maths also. That's not difficult at all. So I'll give you all idea of differentiation, and probably you can start learning from now. Bye guys, take care. See you in the next lecture. And please do start preparing, and I'll try to send some practice questions, but hopefully you will have.
I said thank you, sir.
Good night.